Chapter 17.1, the reasoning of tests of significance. So what's the logic or reasoning behind hypothesis testing? The math actually is not that difficult, as you will see in the next few chapters, but it's always the reasoning, the logic that students find a little bit confusing because it's a little bit anti-intuitive. So let's go through this slowly. So first of all, we make an assumption about the population mean. So mu is some number. For example, everybody says that it takes 4 years to finish college. So mu is 4 years. And then as a researcher, I don't believe that mu is 4 anymore. I think mu is bigger than 4. So what I would do is I'll go out and collect data, and then my data will give me some evidence, hopefully will give me some good evidence against the assumption. So remember, as a researcher, you are kind of like a prosecutor. You're prosecuting the assumption because you don't think the assumption is true anymore. So you're looking for evidence against the assumption. If mu is indeed true, then we expect our sample mean to be close to mu. If mu turns out to be very far, if the sample mean turns out to be very far from mu, that means we have good evidence that our assumption is incorrect. Let's take a look at a simple diagram to illustrate the logic. It's very simple. So in reality, in real life, you only take one sample. You only have one sample mean because conducting even one sample is very expensive. But you don't know where your sample mean will end up. Is it going to be close to mu like this one? It's pretty close. Or it could be in this location. It's a little bit far. Or it will be very far from mu. So among all these 3 possible locations, of course there could be even more, but let's take a look at these 3 possible locations. So which location of your sample mean will give you the strongest evidence? It is the farthest one. So this one, this sample mean will give you the strongest evidence. So let me get rid of that. Will give you the strongest evidence against the assumption. Okay. So let's continue. So what's the bottom line? The bottom line is the more extreme your sample mean is, more extreme meaning the farther out your sample mean is, the more evidence you have. So that's good news. So as a researcher, if you're doing hypothesis testing, you want your sample mean to be as far as possible. You don't have much control over it, but you're just hoping that your sample mean comes back to be very extremely far from the mu, and then you can claim that you have evidence against the assumption.